In my previous video on working with ellipses, I explored several ways to create and edit elliptical shapes. In this video, I'm going to look at ways to leverage those 2D ellipses for the purpose of creating three-dimensional shapes. So in this sample file I've got 6 2D ellipses, and I'll work with these as we go along. Now normally you're drafting within DataCAD's Edit and Utility menus. So if I subsequently press the right mouse button, that's just going to bring me back and forth between DataCAD's Edit and Utility menus. Well, at the bottom of the Edit menu, there is a 3D Menus option. Selecting that will bring you into DataCAD's three-dimensional tools, and when I subsequently press the right mouse button, I'll toggle between the 3D Entity and 3D Edit menus. Later on, if I want to get back to the 2D menus, I can just select 2D menus from the 3D Edit menu. Well, I've got these ellipses and I want to convert them to another entity type so I can take advantage of other capabilities in DataCAD. We're going to look at the Explode command in the 3D menus. And within this menu, you've got options to convert from one entity type to another by exploding it, say in this case from ellipses to lines or to polygons or points. There's a few specialized options here for converting TrueType fonts to slabs and polylines, and for exploding a symbol back into its constituent entities. But for the purpose of this exercise, we're going to stick with lines and points. So while I'm in this menu, DataCAD's asking me to select an entity to explode to lines. And I'll go ahead and select this ellipse up here. And you can see there's a subtle change in the display of that ellipse, but it's not very noticeable. Down here at the bottom, DataCAD's telling me I've exploded an entity which is an ellipse. Well, what have I just done? Well, I've converted that elliptical shape, which was a single entity, into a number of 3D line segments. So I'm going to use the Identify command, which is Shift-I or capital I. And then I'm going to select one of the line segments in this ellipse. And DataCAD comes back and tells me that this is a 3D line, not an ellipse. If I then pick this ellipse below it, no surprise, DataCAD tells me it's an ellipse in one single entity. Well, you can actually control the number of segments that result from the Explode command. In DataCAD's 3D, there are primary and secondary divisions that determine how many segments make up a circular entity. So in the 3D Edit menu, there's a Settings menu. And when I select that, we can see two options here, primary and secondary divisions. Well, it's the primary divisions that I'm concerned with. I'll select that and see that it's currently set to 128 divisions. So when I exploded that ellipse, DataCAD used 128 divisions of a circle to determine how many line segments would result. Well, normally 36 would be sufficient, so I'm going to set that number of divisions to 36, and then I'm going to return to the Edit menu and go back to Explode. And now I'm going to select another one of these ellipses to explode to lines. And then I'm going to do the same thing again, but with a different number of divisions. So I'm going to go back to the 3D settings, select primary divisions, and set that to 12. Now I'm going to go back to Explode and pick this ellipse. And the lower number of divisions is much more readily apparent because we can clearly see the individual line segments that have resulted. Well, to illustrate this a little bit more clearly, instead of exploding to lines, I'm also going to explode to points, just so you can see what's happening here a little better. So I'll go back to Explode, and this time I'm going to select 2 points. And then I'm going to pick the entity below the one that we just exploded to lines, and now we've converted it to points. So we can clearly see the vertices of these line segments that result in this explode. So let's go back to settings and bump our primary divisions up to 36, which is the default. And then explode the ellipse on the left, which corresponds to the ellipse at the upper left-hand corner here. When I pick that one, now we see the result of a 36 division explode. So I'll do one last explode in the middle here. We'll go back to settings, set the primary divisions up to 128, and then explode this to 128 divisions. So the number of divisions that you choose depends on what your modeling purposes are. In general, you want to have fewer divisions and not necessarily have a greater number of divisions when it's not going to serve any benefit. A greater number of divisions is going to make your model less efficient. And in general, when you're 3D modeling, you want to be as polygon or entity efficient as you can be. In other words, you want to have as few entities as possible to represent your three-dimensional model. Well, I'm going to continue working with these ellipses at the top that I've converted. And my next step is to convert them to a covered polyline. So I'm going to go back to DataCAD's 2D menus. I'm going to go into the Curves menu, and within the Curves menu I'm going to select Polyline. Now, polylines in DataCAD are used for many things. Typically in drafting you use them for hatch boundaries or solid fill boundaries. But a polyline can also be covered and have a height value or a thickness. And those covered polylines or profiles, sometimes referred to as extruded profiles, are very useful for modeling three-dimensional shapes. Well, one of the functions within the Polyline menu is called Contour Search. And that's going to allow us to select a group of 3D lines or 2D lines and convert them to a polyline path. So our converted ellipses at the top of the screen are all linked end to end, and we've got a clear path that the Contour Search can follow. Well, before I create these covered polylines based on those line segments above, I'm going to change my layer from the current layer, which is called Ellipses. I'm going to press the Tab key and move to the Polyline layer. Because the Contour Search is not going to remove the original entities, it's merely going to create new polyline entities on top of that. So for modeling purposes, you want to keep things as separate as possible on multiple layers, which makes things much easier to work with as things get more complicated. Or I should say complex. So now DataCAD's asking me to select the inside or outside of the contour boundary search. I'm going to bring my cursor over here and just left click near it, and we can see these nodes have appeared, and that's a clear indicator that we've created a polyline. And I'll just continue selecting the other two boundaries, and you can see the correlation between the points that we created earlier and the vertices on each of these polyline boundaries. Well, now that I've created these covered polylines, I'm going to make that the only active layer and continue working with them. So I'm going to press L for layers, and within the layers menu I'm going to select active only, and I'm going to select the polylines layer. So now that I've got the polylines isolated, let's back out of the layers menu and then take a look at these in 3D. I'm going to click on the color cube up here in the viewer toolbar, and that's going to bring up DataCAD's object viewer, and we can see the three elliptical discs that we've created with the various number of divisions. And as I had indicated before, the number of points being greater here on this center ellipse at 128 is not that much sharper than this one on the left at 36. So you do want to keep that in mind when you're creating these objects. Certainly if this is the only shape that's going to be in my project, 128 divisions is no big deal. But if we're going to end up with dozens or even hundreds of these in various components, then that can become problematic. Let's go back to the drawing and extend our screen. And let's look at how we can now convert these or continue working with them to create, say, the trim that might go around a window or a mirror or something like that. Well, in DataCAD's 2D menus, there is a geometry menu. That's off of the utility menu. And if I select geometry, there's an option within here called offset. And offset is extremely handy. For drafting purposes, you're typically taking 2D lines that you've drawn and then offsetting those for walkways or walls and other types of things like that. But for our purposes, I'm going to use the offset command to offset each of these polyline boundaries. I'll select offset, and then to illustrate how this works, I'm going to pick dynamic and then pick one of these polyline boundaries, and you can see I can dynamically offset that profile. I'll do the same thing here with the ellipse that has 128 divisions, and I can even offset on the inside, but you'll see at some point, because of the high number of divisions, the entity is going to fold back on itself. And that's certainly valid, but probably not what we want. It might be worth noting here that an offset of an ellipse, this result is not an ellipse itself. So with that in mind, we'll recognize that these original shapes are the only true ellipses that we're working with in our model. So instead of dynamic, I'm going to continue with dynamic off, and I'm going to define a perpendicular distance, in this case 4 inches, which is the width of my trim. So I'll select each one of these and then offset to the outside. And that essentially creates an additional polyline that's 4 inches away from the original. Now I'm going to back out of the geometry menu, and I want to go back to the curves polyline menu so that we can convert these inner ellipses to voids that occur inside of these outer ellipses. So for example, if we go back to the object viewer, we essentially see the same thing because these two polyline shapes are sitting on top of each other. So if I go back to the curves menu and select polyline, I can use the voids command to select the outer or master polyline, and then the inner polyline that's going to become a void. Now the void doesn't technically have to lie inside of the master polygon, and you can have more than one void within a master polygon. But for the purpose of this exercise, we're just going to have simply the master outer polygon and the inner void. Now that I'm done with this first shape, I'll right click and then continue with the others. So I'll select the master polygon and the void, right click, select the master polygon and the void, and right click. So now we should have a hole in each one of these. So I'm going to back out of the curves menu and bring up the object viewer. And now we can see we've got 3 trim shapes based on the various divisions that we started with. Now that we've got these shapes, I want to explore working with 3-dimensional primitives, specifically a truncated cone, but this concept can certainly apply to many other 3D primitives in DataCAD, cylinders, cones, and spheres, for example. So I'm going to change my color from white to cyan, and I'm going to create a truncated cone based on the center ellipse. So I'm going to go back to the 3D menus, and then within the 3D menus I'm going to select 3D Entity. And here I see the list of DataCAD's 3D entities, and in particular we're looking at the truncated cone. Now for the truncated cone, DataCAD's going to create the base and height of that cone based on our current Z-base and Z-height settings. If I look down here in the lower right corner, I can see that the Z-base and height are both currently set to 0. Well, I want my cone to extend from a base of 0 and then up to a height of, say, 3 inches. So I'm going to press the Z key. That prompts me to enter the Z-base value, which is going to remain at 0, so I'll hit enter. And then the Z-height value, I'll type in 0.3, which is 3 inches. So now my Z-base extends from 0 to 3 inches. So the height of my resultant cone, or in this case truncated cone, will be 3 inches. So I'm going to use the diameter circle method to create this truncated cone. So I'll go ahead and object snap to the lower portion of this inner ellipse, and then to the upper portion. And then DataCAD's going to ask me for the upper portion of this truncated cone, and I'm going to object snap to the left inner portion of the ellipse. So now I've got a truncated cone that falls within the top and bottom extents of this ellipse. But now I have to figure out how to essentially squash this cone, this truncated cone, to fit inside of this ellipse. Well, in the previous video on working with ellipses, we looked at the calibrate function in the enlarge menu, which allows us to figure out an enlargement along one axis, say in this case along the x-axis, so that we could reduce or stretch this truncated cone down to fit inside of this ellipse. So I'm going to back out of the 3D menu here and go back to 2D menus and go to the enlarge command. DataCAD's asking me for the center of enlargement, and for convenience I'm going to select the center of this truncated cone, or more specifically I'm going to object snap to the center of it. And then we're going to go into the enlargement submenu and select calibrate distance. Now we're going to use the by points method to tell DataCAD what distance we want to figure out the multiplication factor for to end up with another. So the first distance is the center of the truncated cone, and then the second point is going to be the outer edge of the truncated cone. So that's the first distance. Now the new distance is going to be from the center of the cone to the inner edge of this ellipse. So I'll object snap there. So now DataCAD has figured out that if we multiply the original width of this truncated cone by 0.63, it'll match the inner width of that original ellipse. But by default, that resultant factor gets applied to both x and y enlargements. And we don't want to change the y distance, or the height of this truncated cone. So I'm going to set the y enlargement back to 1, so that remains unchanged. Now I'm going to right click to go back to the enlarge menu, and now I can select this truncated cone entity to enlarge. and we see that it gets squashed in the x direction. Well, it looks pretty good, but because of the disparity between the divisions of the truncated cone that I created and the divisions of the ellipse that I created, there's a bit of a mismatch here. Well, it's pretty easy for me to change the divisions of this truncated cone to match the original ellipse that we exploded. So what I'm going to do is copy this truncated cone to each one of these elliptical shapes because they're the same. So I'll hit C for copy, and then the first point of distance to copy is going to be the center of this truncated cone, and I want to put that in the center of this ellipse, but there's no center point for me to snap to. So what I can do is use DataCAD's getSnap function, and I do that by pressing the Shift key and the middle button, and that brings up a context menu, and I can tell DataCAD that I want to get just the x distance between the 2 points that I snap to. So I'll select Get X, and DataCAD comes back and says the distance to copy is 8 feet at an angle of 180 degrees, and that's correct because 180 degrees is to the left of the screen by default. And I'll go ahead and pick this entity. So now we've duplicated that over here. This ellipse had 36 divisions, so there's still a mismatch between this truncated cone at 128 and this ellipse at 36. Well, I want to copy that again, but I want to copy it at half the distance, so I'm going to use this distance divided by 2 function, and when I pick that, it's going to reduce the distance from 8 feet to 4 feet, and I can then pick this entity again and put it in the center. Well, this center ellipse and the truncated cone have the same number of divisions at 128, so there's a perfect match between them. So this is something to keep in mind when you're combining multiple three-dimensional shapes, like a cylinder and a torus, for example. But now I need to change the divisions on these two truncated cones, so I'm going to back out of the copy command, and then I'm going to double-click on this truncated cone and bring up its properties. One of them is the divisions, and I'm going to change that from 128 to 12 and click OK. And now that matches the original ellipse that we exploded perfectly. And I'll do the same thing to this truncated cone and change it from 128 to 36. And now that matches perfectly. Well, let's take a look at that in the object viewer. And it's very subtle. You can see the beveled centers that we've created. But so we can see that a little bit better, I'm going to change the material on each one of these truncated cones. So again, I'll double click on that entity to bring up its properties, and one of them is the material, which I'll change to glass. And I'll just do the same for each of these other cones. And then bring this back up in the object viewer. And now we can see the result of that. So certainly the ellipse in the center with the greater number of divisions is much smoother, but you have to decide for your own modeling purposes which is appropriate. Now in this drawing I have an example of an oval window that I created for another project. So I'm going to go to DataCAD's Go to View menu, so that's V for Views, and I'm going to select the previously saved view called Window, and that's going to bring up an oval window that I created using the exact same methods that we discussed today. Just take a quick look at that in the object viewer. So I hope this has given you some insight as to how you can leverage one type of entity in DataCAD, something that you've constructed in 2D, to form the basis of something that you might model in 3 dimensions. And as always, thank you for listening, and if you have any questions or comments, please enter them in the area below this video.